and then look at some. All right, tangents. A tangent to a circle. A tangent is a line, this line here. At a given point is a line passing through the point that touches the circle only once. That's something you need to remember. The tangent, when you see tangent, it's a line that touches the circle only once. So in this case, suppose P supposed to be is a given point on the circle. In the diagram below, the line drawn is a tangent at P. So this is P here. On this line, let me just highlight it in red. This line is the tangent. And notice it only touches the circle at this point P. That's something you need to remember. Tangent touches the circle only once. Another thing you need to note is the diameter. So let me put this in green. The diameter. So we know that the diameter connects two ends of the circumference and it passes through the center. The diameter and the radius is half of the diameter. So this would be my radius, the red line, half of the diameter, right here. This is the radius. And you need to notice that the diameter and the radius, they are perpendicular to the tangent. So let me put the tangent in blue. The blue line is the tangent, the red line is the radius. And I need you to remember that these two are perpendicular. That means that they meet at right angles. That's something you need to know for later on, and you'll see why. So, everybody good with that so far?
Yes, miss.
Yes, miss.
Yes, miss.
All right. So we're moving straight to the examples. Find the equation of the tangent to the circle x squared plus y squared is equal to 5 at the point 1, 2. First thing you need to remember, for new people, don't worry, we did that already, and the recordings are in the Google Classroom, so if you want to look at it, no problem. So first thing you need to recall, if you're given the equation of a circle, oh my, I have heat. I'll change that. If you're given the equation of the circle and it's in the form x squared plus y squared is equal to r squared, then we know that the coordinates of the center is 0, 0. So that circle, the center is the origin. So let me show you what that circle will look like. If you ever see this form of the circle, x squared plus y squared is equal to r squared, that means, say this is my y-axis, y, this is x, my center would be here, the origin. What the coordinates is 0, 0. Let me just draw that circle. So here, that's supposed to be a circle, huh? So that's what that circle will look like. Every time you see the equation of the circle in this form. What we learned, people who were in class, we also learned the standard form of the circle, so that's x plus h squared plus y plus k squared is equal to r squared. That's the standard form. And we also learned about the general form of the equation of a circle. So x squared, hold on, let me just, don't want to confuse anybody. So this one here, this is standard form. Standard. And this one here that we're going to do now, this is called the general form. General. For the new people, if you didn't know how we get the general form, all we do is that we expand the standard form. So if you don't know about that, it's in Google Classroom, the recording is there. So the general form of the equation of a circle is x squared plus y squared plus 2hx plus 2ky plus c. And unlike the standard form that's equal to r squared, the general form is equal to 0. It's okay if you've never seen this in your life, you're recording today. When you see it in this form, that just means that the circle, so the coordinates is not, the center of the circle is not 0, 0. So let me just, so say my center is 1, 1. This is y, this is x. Just showing you what a circle might, one of these circles might look like. So this would be my center. This would be my center right here. And then my circle, let me do this in blue. Right. When you see this one, x squared plus y squared is equal to r squared, the center is always 0, 0. When you see this one, well, the center would not be 0, 0. That's what I'm trying to say. Okay. All right. Okay, back to this question. Now we know that the center is 0, 0. When they want you to find the equation of the tangent, just follow these steps, right? So first step, you need to find the coordinates of the center. And we know, since it's in this form, x squared plus y squared, we know that the center is automatically 0, 0. The center is the origin. Next step, we need to find the gradient of the radius using the point, the given point, and the center. So look up here. The given point is 1, 2. Center is 0, 0. And we're trying to find the radius. I mean the gradient of the radius. Let me go back. For the people who don't know, don't worry, we did this already. We know that the formula for gradient is y2 minus y1 over x2 minus x1. And this also means the change in my y values over the change in my x values, right? So we know that. Let me just draw this. It's okay if you do a little sketch. Nobody's going to penalize you for that. If you think it would help you, you go ahead. The given point, just to write it to the side here, is 1, 2. Center, 0, 0. This is my y-axis, this is my x-axis. The center 0, 0, that's the origin, and the origin is always here. This intersection between the y-axis and the x-axis. And they told us that the given point is 1, 2. So if I was to draw a sketch of this, I would say that this is 1, and probably like here is 2. So then I'll draw a point there. Let me put it in green. So this is where my point would be. Why? In case anybody doesn't know, you would draw a horizontal line here, a vertical line here, and that's how you get that point. Right? Now to draw the circle. So this is what my circle would look like. Where the center is the origin, so 0, 0, and then 1, 2 is a point on the circle. And the step that I told you just now, it states that you have to find the gradient of the radius. This is the radius from the center to a point on the circumference. Let me write the points. So this is my given point, which has the coordinates 1, 2. And this is my center, and we know it has the coordinates 0, 0. Now to use this formula up here to find the gradient. So just substitute your values. Say I want this point to be x1, x2 and y2. Hold on. Just for new people, in case you didn't know, a coordinate. Is in the form x, y. So x, this is my x value, and then this would be my y value. Looking at the point 1, 2, 1 is my x value, so that's why it's on the x-axis. This is my x-axis, that's why 1 is on the x-axis. 2 is my y value, and that's why it's on the y-axis. Just in case you didn't know, right? Now to substitute the values. The formula states y2 minus y1 over x2 minus x1. We said that we want y2 to be 2, so I'll just write 2 here, minus y1 would be 0, divided by x2 is 1, and x1 is 0, so that's minus 0. 2 minus 0 is 2, and then 1 minus 0 is 1. So that means in this case, for this example, that my radius would be equal to 2. Everybody understands that? Yes, no?
Yes, miss.
All right.
Yes, miss.
Okay. All we did, we just found the gradient for the radius. All right. Okay, you see here, m is equal to 2. Oh, for people who didn't know, gradient is denoted by m. All right, so I could put gradient is equal to y2 minus y1 over x2 minus x1, or I could put m is equal to y2 minus y1 over x2 minus. Hold on, let me just write that out in case for my visual learners. So m is equal to y2 minus y1 over x2 minus x1. So I could write this, gradient is equal to that, or I could write m is equal to that. All right, just for the visual learners in here. Okay, the third step is to find the gradient of the tangent line. This is a hint here, the radius and the tangent are perpendicular. Remember I told you to note that from this slide, look, the diameter and the radius are perpendicular to the tangent. This is your radius in green. This is a tangent in red. And you can see they are at right angles to each other. Let me not use blue. You might not see that properly. And they are right angles at each other, So that means that they're perpendicular. Everybody seen that they're perpendicular?
Yes, miss.
Miss.
All right, just make it sure. We know from the previous class when we did straight lines and the coordinate geometry, we know that perpendicular lines, the product of their gradient is -1. So in this case, m1 would be the gradient of the radius. So I put this, m1 is the gradient of the radius. So I put grad of r. M1 is the gradient of the radius. M2 would be the gradient of my tangent. M2 gradient, we'll just put grad of tangent. And since they are perpendicular, the product of their gradients would give me -1. We found out before, just now, and just go back, that the gradient of the radius is 2. M1 is 2 times M2, which is the gradient of the tangent, would give me -1. So now we need to find what exactly is the gradient of the tangent. Why? In case anybody was wondering, they want me to find the equation of the tangent, equation. And we know when we did straight lines that the general form of a straight line is y is equal to mx plus c. And that's what we're aiming for. We're aiming to get this form. And that's why we're trying to find m, to put it in this form, just in case anybody was wondering, right? So 2 times m2, which is the gradient of the tangent, would give me -1. So now we need to find out what the gradient of the tangent is, because we need it in the form y is equal to mx plus c. Right. And to do that, we need to divide by 2 on both sides. So this is just transposing. Let me write it out. Let me use. So 2 times m2 is equal to -1. We would need to divide by 2 on both sides because we want m2 alone. So divide this by 2, divide this by 2. These 2's would cancel. So what I remain with, m2 is equal to -1/2. And that's why the gradient of the tangent, which is m2, is -1/2. Everybody good with that?
Yes, Miss.
Yes, Miss.
Okay. If you get lost along the way, just let me know. The fourth and final step. We did this already for straight lines. So I have coordinate geometry straight lines. Right, just in case you need a refresher or you never did this before, it's fine. Just look at that. We know the 2 methods to find the equation of any line. We could use first method, y is equal to mx plus c, right here. Or we could use the second method, y minus y1 is equal to m x minus x1. That's a formula you need to know. Well, you could use this method or you could use this method. But when we are doing that topic, most of the class preferred the second method. But don't worry, I'll do both of them. All right. When finding the equation of a line, you need to remember this from the straight line slide. You need at least 1 point, right? So, okay, and I need to note this as well. I have given point underlined in italics and in bold because this is very important. And let me show you why. Y-axis, x-axis. The center, let me just write down the information here. The center, we know, is the origin, which is 0, 0. And then they gave us the point 1, 2. They said that's a point on the circle. This is my center because this is where the origin is, the intersection between the y-axis and the x-axis. I'll just say that this right here is 1 and like this is 2. This is just a sketcher, so it's not accurate. This would be my point here, because if I draw a horizontal line here and a vertical line here, that's where they intersect. Right. So let me just draw the circle now. Circle. What you need to remember, tangent, it meets the circle. It touches the circle only once. And in this case, they told us that it passes through this purple point right here. Just highlight it a little more. This purple point right here. So what does that mean? My tangent will look like this. Well, that's not accurate because it cuts 2 points on the circle. But I can't really do anything about that. Oh my gosh. Okay. It's only supposed to touch one point in the circle, which is this purple point right here. So you need to remember that, but my diagram is kind of wonky, right? So it's only supposed to touch this purple point right here because the tangent only touches the circle once. Remember this, only once. This is my radius. This is my radius right here. I'll name this R. I'll name the tangent T. Why I said that we need to use the given point when finding the equation of the line and not the center, it's because of this. We know, let me erase. We know to find the equation of a line, y is equal to mx plus c. We could use this method, or we could use this equation, y minus y1 is equal to mx minus x1. But what you need to recall though, when using these two methods, you're using the gradient of the line. So gradient, so I'll just use m of the line. And the next thing you need to use to find, the next thing you need to find the equation of the line is a given point. So let me put given point. I need to put this in a different color because it's very important. A lot of people might make mistakes with this. I don't want you to. Given point on the line. The given point must be on the line. So why I said we can't use the center, I want to find the equation of this green line here. But could anybody tell me the center, which is this red dot here, is the center touching this green line? Is the center on this green line? Yes or no?
No, miss.
No, it's not. But this purple dot is. And that's why when we find in the equation of the tangent, we have to use the given point. So the purple point in this case, which would be 1, 2, and we cannot use the center. You understand that? If I lost you, let me
Yes,
know.
miss.
Okay. Could one more person answer me?
Yes, miss.
All right. I just wanted to make that clear because a lot of people make that mistake. Don't do that. Don't be a lot of people. Right. Okay, let me just. For people who want here, the people who need a refresher, we have the given point. We have the gradient, which is minus a half. This is the gradient of the tangent, and this is a given point on the tangent. So now to find the equation, we could use, let me use the first one first. We could either use this first one, so this is method 1, y is equal to mx plus c, and just substitute your values. Let me use the other. What you need to remember, a coordinate is in the form x, y. So that means that 1 in this case is my x value, and 2 in this case is my y value. And that's why here I would replace, and let me just continue together. So I said 1 is x, 2 is y. The equation wants me to put y first, so I'll put 2 here, because 2 is y, is equal to m. We know m is minus a half times x. We know x is 1, so we put 1 plus c. Now we need to transpose. Transpose just means to make something the subject of the formula. So we're trying to make c the subject of the formula to find the value of c. 2 is equal to minus a half times 1, which is minus a half, plus c. So now we need to add a half on both sides to get c by itself. So 2 plus a half is equal to c. 2 plus a half is 5 on 2 is equal to c. So now I could rewrite this. I could rewrite this to get it in the form y is equal to mx plus c. So you put back the y. Remember, if you don't know what I'm talking about, let me know. Okay, so y is equal to m. We know m is a minus a half, so you put minus a half. You put back x, and we know that c is 5 on 2. So you put plus 5 on 2. And this is my answer right here. Everybody good with that?
Yes, miss.
Yes, miss.
Okay. Remember to let me know if I lost you. Anyway, like, if I lost you at any point, let me know. Even if it's the smallest thing, like how I got 5 on 2, let me know. We need to make sure you understand everything. All right. Now we get to practice this a little more. So let's do past paper questions. You could just write down the year and the number if you want to. Doing paper 2, 2011, number 3, part 2. Where's my document? Okay. I'll send this to you at a later time. Don't worry. I compiled all the fun and geometry questions in paper 2 here. But I'll send this to you. So you don't need to bother about writing down the question. Just write down the year, paper 2, and the number. And this is the one we're doing right now. This one. So let me ask you a question now. Do you want to attempt this by yourself? Or do you want me to go through it with you? And then you could attempt the others by yourself. Anybody? Attempt it by yourself? Or you want me to go through it with you and then attempt the others by yourself?
I could attempt it.
Okay, we have one for attempt. Anybody else?
Yes, miss. I'll try it.
Okay, one more person. Attempted. Oh, let me go through it with you. Anybody? Okay, you'll attempt it. Also go through it with you after. I just want you to attempt it by yourself, please. I'll give you just one more minute to finish this, and then I'll go through it with you. All right, let's do it now. So remember, for any question you're given, the first thing you want to do, write down all the information that they gave you. So they told us that the equation of the circle is x squared plus y squared minus 4x plus 6y is equal to 87. And they also told us, they gave us this point, minus 63, and then they said that the tangent passes through this point. Right? What you need to notice is that this right here, like I said, don't worry, the people who weren't here, it's all in Google Classroom. You need to notice that this is in the general form. So recall the general form of the equation of a circle is x squared plus y squared plus 2hx